Hello, today we'll discuss different types of dies and design of piercing and blanking punches. So, the first type is conventional dies. Punch holder fastened to the ram of the press. Die shoe fastened to the bolster plate. Punch is fastened to the punch holder and aligned with the opening in the die block using guide pins. Stripper holds the scrap strip so that the punch may pull out the hole. You can see in the diagram. There is a ram, there is a shoe, there is a punch holder, and guide bushings are there. So these are guide bushings, and this is a punch, and this is a blank, this is a die, and this is a die holder, this is a die shoe. So you can see in the diagram. So this is a conventional position of the die set, where at the top there is a ram and then punch holder, and punch is there, and at the bottom the bolster plate, die shoe is there, and die is there. So in between the workpiece is placed, and stripper is there, it is used. Also there push-up pins are used. So this is a conventional position of die set. Then second type is inverted dies. Punch and die positions are interchanged. Interchange means in inverted dies, the punch is at a bottom and the die is at top position. Here there is a die and this is a punch. So it is an inverted position. Why this is inverted? The reason, the opening in bolster plate is too small to permit the finished part to pass through bolster opening. The die block fastened to the punch holder and punch fastened to the die shoes. As the ram descends, the blank is sheared from the strip. The punch is forced through the scrap strip, and a spring attached to the stripper is compressed and loaded. On the upstroke of the ram, the shedder pushes the blank out of the die opening. The stripper forces the scrap strip of the punch. So this is a diagram of inverted dies, where this is a punch. Okay, so this is a punch, this is a blank, this is a die. So the die is held in a punch holder and punch is held in a die shoe. Okay, so the remaining position is similar, but it is an inverted position. Here punch is at a bottom side and die is at upper side, and the pressure received from the ram is supplied to the die, and die will ascend and descend, while the forward stroke die descends and for return stroke die ascends. So whereas in previous case, in conventional dies, the punch is at the top and die is at the bottom, but in inverted dies, the punch is at the bottom and die is at top. So this is the difference. The next is a compound die. So compound dies, so combining the principle of conventional and inverted dies in one station is compound die. So workpiece is pierced and blanked in one station and in one operation. So piercing punch is fastened in conventional position to the punch holder, and a die opening for piercing is machined into the blank punch. In compound dies, the blanking punch and blanking die opening are mounted in an inverted position. The blanking punch is fastened to the die shoe and the blanking die opening is fastened to the punch holder. So this is the combination of conventional die as well as inverted die. Here what is important? The blanking punch is fastened to the die shoe and blanking die is fastened to the punch holder. Also, the piercing punch is fastened to the conventional position to the punch holder and piercing die opening, means die opening for piercing, is machined into the blanking punch. So there are at a time simultaneous two operations are performed. Here in this diagram you can see. So here the piercing die is there and piercing punch is there. So piercing punch is held by the punch holder. It is as a conventional, and die is held with this die shoes. So this is a conventional piercing. Okay. So this die is conventional type, whereas this blanking, so this is a punch and this is acting as a die. Okay. So this is acting as this is a die and this is acting as a punch. So this die is inverted and it is fitted with so this blanking die is fitted with the punch holder, whereas blanking punch is fitted with shoes. Okay. So this is what the compound die. Let us see one small video in which we can understand the working of compound die. Will this is one small example from one small scale industry. Let us see one more example.
The working principles of a compound die. The compound die shown in here is used to produce washers, a round metal piece with a round hole in the middle. The compound die produces the washer with a single stroke. When the ram descends, first it squeezes the metal strip in between the pressure pad shown in yellow and the top die. When the ram continues descending, a round washer is cut with the red bottom punch and the top die. During the squeezing and cutting process, the top stripper stops descending due to the contact with the red bottom punch. This exposes a smaller punch at the top. Since the ram continues descending, the small top punch cuts a smaller round piece from middle of the washer. This scrap piece falls down from the opening in the red punch. As soon as the scrap piece is cut and cleared from the bottom die, the ram begins to ascend. During this process it brings the strip back to its original position where the punched washer is. Then a feeding mechanism, not shown in the animation, pushes the strip forward for the next operation. While the strip is advancing, the processed washer advances with it, in the opening where it was before the cut. As soon as the strip reaches a position where it cannot hold the washer in the groove, the washer falls to a container located next to the punch press. At this point, the cycle restarts. If there is a danger that the washer may stick on the stripper, push pins should be added on the stripper to prevent catastrophic failures. To understand the cutting operation much better, it would be beneficial to show a top view of the metal strip. As you can see, when the strip advances to the cutting position, the washer is cut with a single stroke and placed in the groove where it was before the cut and carried away with the strip. compound dies are usually used for producing simple pieces. Since 2 or more operations are performed in one punch, the press stroke is longer. The longer stroke reduces the number of parts produced per minute. These dies are also more expensive to manufacture. The number of pieces to be produced should just...
So we watched a small videos of compound die, which we seen two videos, one from industry where with the help of pneumatic mechanism, pneumatic application, the strip is fed to the compound die, and the compound die operation, that is piercing and blanking at a time, it was processing. So also we seen one animation, so animation of same operation we discussed. So this is what the compound die. So this is a expensive one, but simultaneous two operations can be performed. It is suitable for mass production. Then next is a progressive die. These dies perform two or more operations at different stages. Every time the RAM descends, the stock strip is advanced through a series of stations that perform one or more distinct operations on workpiece. A strip must move from first through each successive station to produce a complete workpiece. The distance from one station to the next station must be same. Means the operation which you want on final product, it is done progressively. It is carried out progressively on a different punch set and die sets. So each operation perform an operation on the workpiece so that the workpiece is completed when the last operation has been accomplished. For a 4-station die, each successive stroke will produce a finished part. Operation can be performed are piercing, blanking, forming and drawing. So this is the step. So in first step, so this operation carries out, then it is continued to next, then it is continued to next, then it is continued to next. In this, the step by step, as it progresses, the next operations are carried out and you will get the final product. You will get final product. So this is what the progressive die. We will see one small video. So this is about progressive die, where so each operation performs an operation on the workpiece so that the workpiece is completed when the last operation has been accomplished. So here the step by step the progresses, operations are completed. Okay, so next type of die is combination dies. So in these types of dies, cutting operation is combined with non-cutting operation. The cutting operations may include blanking, piercing, trimming, etc., and are combined with non-cutting operations like bending, extrusion and forming. So this is called combination die. In case of compound die, there are two cutting operations, piercing and blanking operation. In progression, there is the step-by-step process. So in combination dies, so cutting operation is combined with non-cutting operation. So this is what the difference. As we know that in combination dies, the cutting operation is combined with non-cutting operation. It may be include blanking, piercing, trimming, etc. So you can see in this diagram the combination die. So here it includes the blanking as well as bending operation, drawing operation. So in this diagram you can see the blanking punch is there, and the punch is having the profile. It will also gives a drawing a different shape, cup shape to the blank. So in this way the simultaneously blanking operation takes place as well as the bending operation or drawing operation takes place. Okay, this is about different types of dies. In next session we'll discuss punch design. Okay, now we'll stop here first session. Thank you very much.